Hi there science students, this is the third and final video on projectile motion. We're going to focus on how the velocity of an object changes when it's projected horizontally. Just going to replay this animation from earlier. We'll go up to this point here. This object is now traveling exactly horizontally. It has a horizontal velocity Vx in the horizontal direction. That's going to remain constant throughout the flight. The vertical velocity at this point, this green arrow, well, it's 0 right now at the top of the flight, but as the object continues its motion, that vertical velocity will increase because we have accelerated motion in the vertical direction. So by the end of the flight, we have a resultant velocity. The object is going in this direction with that level of velocity, but that is made up of the components of the horizontal and vertical velocity. So we need to be able to calculate these components separately in order to calculate this resultant velocity. So let's look at how we do that. For the cannonball example from earlier, we have a horizontal velocity of 1 meter per second. So at the beginning, the horizontal velocity is 1 meter per second. 3 seconds later, that hasn't changed. That remains constant. Now the vertical velocity, on the other hand, that's accelerated motion. Just like a dropped object, this starts at 0 meters per second. We can use suvat to calculate its velocity 3 seconds later. 3 seconds, accelerating in the vertical direction, so acceleration due to gravity. We're finding the final velocity from an initial velocity of 0. So the first law of motion, V equals U plus AT, can be used. So 9.81 by 3 gives us 29.43 meters per second. So vertically, after 3 seconds, it's sped up to that. So let's look at how we could calculate a resultant velocity based on that. What is the actual magnitude and direction of that velocity at the end? So we take the components of those two vectors, the horizontal velocity, which is at 1 meter per second, and the vertical velocity, which is much larger, at 29.43 meters per second. Now they form a right angle triangle. So we can use Pythagoras Theorem to get the magnitude of the resultant velocity. I'll call it V-res. You might want to pause the video and see if you can figure that out yourself, then I'll show you what to do. Okay, so the resultant velocity is equal to the square root of the horizontal velocity squared plus the vertical velocity squared. So that gives us 29.45, we'll say. Now we also need to calculate the direction by finding that angle below the horizontal. So we can use the inverse tangent of the opposite side, the vertical velocity, divided by the adjacent side, the horizontal velocity. And that gives us 88.1 degrees. And there's that calculation there. So we would say 29.45 meters per second at 88.1 degrees below horizontal. Okay, now I'm going to do this example with you guys using the same principles as earlier. The time taken to reach the ground, then finding the horizontal and vertical velocity, and finally using Pythagoras Theorem to resolve those into a resultant velocity. So you might want to pause the video and try this yourself, and then I'll have a go at it. Okay, I'm going to have a go at it. So the time taken to reach the ground. Well, we can use SUVAT to do that one. S, U, V, A, and T. So we want to find the time. It's accelerating at 9.81 meters per second squared. And from a height of 2 meters, staying at a speed of 0 meters per second. Okay, now you might remember that this means that the displacement is equal to half AT squared, so that rearranges to T equals the square root of 2S on A. So that's that little formula we can always use in any situation for projectile motion to find the time taken to hit the ground. Because our projectiles are projected horizontally, they have zero velocity in the vertical direction. So that's the equation for time. So in this case, 2 times 2 over 9.81. 2 by 2 over 9.81. So 0.639 seconds. Right, so the horizontal velocity, I'll call this Vx, our horizontal velocity. I'm going to find here. Now we just use this formula, V equals S over T. Okay, so for this one, in fact, the velocity is constant. That's why we'd be using this formula for the constant velocity, and that stays the same throughout. So it's just 5 meters per second by the end. Now, we are going to need to do a calculation for the vertical velocity, Vy, and we'll use SUVAT to do this. So we know that it's from a height of 2 meters with an initial velocity of 0. We're trying to find that final velocity. The acceleration is 9.81 meters per second squared, and the time is 0.639 seconds. So I'm just going to use the first law of motion here. V equals U plus AT. If you use the second law of motion, that's okay as well. You get a very similar answer. So 9.81 times 0.639. So it's going at 6.27 meters per second. So that's our Vy. Okay, so what we find here is that we have a horizontal velocity by the end of 5 meters per second and a vertical velocity of just a bit bigger, 6.27 meters per second. So we're going to use Pythagoras Theorem to find this resultant velocity. So the magnitude using Pythagoras Theorem. If you haven't tried that yet, go ahead and pause and give it a go, and then I'll do it. Okay, so V res equals the square root of the horizontal velocity plus squared plus the vertical velocity squared, which gives us 5 squared plus 6.27 squared 8.02 meters per second. So there's the magnitude of the resultant velocity. Now, of course, we also need to calculate the direction below the horizontal, or the angle below the horizontal. I'll just call it theta. So theta is the inverse tangent of the vertical over the horizontal. Which gives us (51.4 degrees). So it's at 8.02 meters per second, 51.4 degrees below horizontal. All right, thanks for watching, everyone. Go ahead and try the next example with this motorcyclist driving off a cliff, and there'll be further projectile motion questions in the assignment.